Okay. Let's start.
Yes, ma'am.
Okay. Yesterday we were seeing about exceptions. It's you're able to see the presentation recording fine. Okay. Okay, yesterday we have started with exceptions. So why do we need exceptions is this we have done. So this exception handling, we feel that there may be some error in the code, and we don't want the project or a program abruptly end. So instead of that, avoiding that, we are using the exception handling. An exception handling is an abnormal condition that arises in a code sequence at runtime. In other words, an exception is a runtime error in computer language that do not support exception handling. Error must be checked and handled manually, typically through the use of error codes. This approach is as cumbersome as it is troublesome. So Java exception handling avoids these problems and in the process brings runtime error management into the object-oriented world. Exception handling fundamentals and Java exception is an object that describes an exceptional, that is error condition that has occurred in a piece of code. When an exceptional condition arises, an object representing that exception is created and thrown in the method that caused the error. That method may choose to handle the exception itself or pass it on. Either way, at some point, the exception is caught and processed. Exception can be generated by the Java runtime system or they can manually generated by the code. Exception throws by Java related to fundamental error that violate the rules of the Java language or the constraints of the Java executional environment. Manually generated exceptions are typically used to report some error conditions to the caller of a method. So Java exception handling is managed using 5 keywords. One is try, catch, throw, throws, and finally. So we know that when we use a try and catch, a suspected code segment is kept inside the try block. So we feel that there may be some error in this code. Uh, because because we are the people who are writing the code and we feel that there may be some error in this line or there may be some possible thing, something may go wrong in this particular lines of statement, then we use a try. And when we are using a try, then we have to use a catch block. So why we are using a catch? So in catch, we are creating an object and displaying that in the catch block. So that's the reason catch is used. That's what you can see here, catch. The remedy is written within catch block. So throw, whenever runtime error occurs, the code must throw an exception. It throws if a method cannot handle any exception by its own or some subsequent methods needs to handle them. Then a method can be specified with throws keyword with its declaration. Finally, the block should contain the code to be executed after finishing a try block. So the general form of exception handling is try, catch, and catched. So what is try? Block of code to monitor errors. Then catch, exceptional type 1, exceptional handler for exception type 2. So that's what here we can see, try and catch. So then finally block of code to be executed after try block ends. So then in the exception types, there are all the exceptions are derived class of built-in class, that is throwable. So it has two subclasses, that is exception and errors. So we have a derived class in the exception type, and that is a built-in one where that is called as a throwable. It has two subclasses, exception and errors. So that's what here we can see, throwable, exception and error. So again in exception, we have a runtime exception that is automatically defined for programs. Customized exception, user defined class to handle own exception. Then error, customized exception, user defined class to handle own exception. So exception class is used for exceptional conditions that user programs should catch. We can inherit from this class to create our own custom exception type. There is an important subclass of exception called runtime exception. Exception of this type are automatically defined for the programs that you write and include things such as divide by zero and invalid error of index. So error class defines exceptions that are not accepted to be caught under normal circumstances by our program. Exceptions of the type error are used by the runtime Java runtime system to indicate errors having to do with the runtime environment itself. Stack overflow is an example of such an error. Uncaught exception, let us see what happens if we do not handle exception. Class exception, that is public static void main string int d equals to 0, int a equals to 42 by d. So when the Java runtime system detects the attempt to divide by 0, it constructs a new exception object and then throws this exception. This causes the exception of exception 0 to stop, because once an exception has been thrown, it must be caught by an exception handler and dealt with immediately. Since in the above program we have not supplied any exception handler of our own, so the exception is caught by the default handler provided by the Java runtime system. Any uncaught exception is handled by default handler. The default handler displays a string describing the exception, prints a stack trace from the point at which the exception occurred, and terminate the program. Here is the exception generated when above example is executed. Java.language.arithmetic exception slash by 0. So at exception.main. The stack trace displays class name, method name, file name, and line number, causing the exception. Also, the type of exception thrown, viz. Arithmetic exception, which is the subclass of exception, is displayed. The type of exception gives more information about what type of error has occurred. The stack trace will always show the sequence of method invocation that lead up the error. Class exception, so that is a static void subroutine, and in that we are doing d equals to 0, a equals to 10 by d, public static void main, that is string arguments, so then subroutine. So there is a result stack trace from the default exception handler, shows how the entire class stack is displayed. Java.language.arithmetic exception divide by 0 at exception subroutine, exception 1 main. Using try and catch, handling the exception by our own is very much essential, as we can display appropriate error message instead of allowing a Java runtime to display a stack trace. It prevents the program from automatic or abnormal termination. To handle runtime error, we need to enclose a suspected code within try block. Class exe execution. So the public static void main for any of the Java program, it is compulsory. Then here two variables are declared, that is d and a. Then try and catch block. So d is equals to 0. Then a equals to 42 by d. Because d we have told it as 0. So anything is divisible by 0 turns to be infinite. So then this becomes a problem. So we'll say we are catching that. So again, in this, there are two types of catch. It may be arithmetic exception. So we say divide by 0, or it can be after catch what it is happening. So the goal of most well-constructed catch clause should be resolves the exceptional condition and then continue on as if the error handle had never happened. So import java.utility.random class handle error. Public static void main string arguments int a equals to 0, b equals to 0, c equals to 0. Then the random r equals to new random for int I equals to 0, I is less than 10, I plus plus, try b equals to r dot next integer, c equals to r dot next integer, a equals to 1, 2, 3, 4, 5, divided by B divided by C. Then that is a catch. That is arithmetic exception E, and division by 0. That is A equals to 0. System.out.println, that is A. The output of the above program is not predictable exactly, as we are generating random numbers, but the loop will execute 10 times. In each iteration, two random numbers B and C will be generated. When their division result is 0, then exception will be caught. Even after exception, loop will continue to execute. Display a description of an exception. We can display this description in a println statement by simply passing the exception as an argument. This is possible because throwable overrides the toString method, so that it returns a string containing a description of the exception. That is catch arithmetic exception system.out.println, that is the exception A equals to 0. So that's what here displaying a description of an exception. Multiple catch clause. In some cases, more than one exception could be raised by a single piece of code. To handle this type of situation, you can specify 2 or more catch clause, each catching different types of exception. When an exception is thrown, each catch statement is inspected in order, and the first one whose type matches that of the exception is executed. After one catch statement executes, the other are bypassed, and the execution continues after a try and catch block. So that is a class multiple catch, public static void main string arguments, then try. So int A equals to arguments dot length system.out.println, then int B equals to 42 divided by A, then catch arithmetic exception system.out.println, then catch array index out of bound exception, then system we are displaying the divide by 0, and we are displaying array index out of bound. So then after try and catch block. While using multiple catch blocks, we should give the exception type in a hierarchy of subclass to superclass, because catch statement that uses a super class will catch all exceptions of its own type plus all that of its subclasses. Hence, the subclass exception given after superclass exception is never caught and is a unreachable code, that is an error in the Java. Class super subcatch. So then public static void main and string. Then here we are taking try A equals to 0, B equals to 42 by A, then catch exception E, then system.out.println, generic exception caught, then catch arithmetic exception E, system.out.println, never, this is never reached. Nested try statement. The try statement can be nested. That is, a try statement can be inside the block of another try. Each time a try statement is entered, the context of that exception is pushed on the stack. If an inner try statement does not have a catch handler of a particular exception, the stack is unbound, and the next try statement catch handler are inspect for a match. This continues until one of the catch statements succeeds, or until all the nested try statements are exhausted. If no catch statement matches, then the Java runtime system will handle the exception. Class nest try, public static void main, int try. How many tries? Multiple tries. That's what here nested try within one more try. Int A equals to arguments dot length, int B equals to 42 by A, system.out.println, try. If A equals to 1, A equals to A minus 1. If A equals to 2, then int C equals to 1, C 10 equals to 99. That is catch array index out of bound, and E. Then catch arithmetic exception system.out.println, divide by 0, then by 0. So when a method is enclosed with a try block and a method itself contains a try block, it considers to be a nested try block. Then class nested, how the nested class is working. Static void nest try. If a equals to 1, a equals to a minus 1. If a equals to 2, then 1. So then we are assigning a42 as 99. And catch array index out of bound exception is occurring, and that is caught in the object, and that is displayed here. Then the main method, so where a is a arguments dot length and b equals to 42 by a, then system dot out dot println, we are calling that nested try and function catch that and divide by 0. So then throw, till now we have seen catching the exception that are thrown by a Java runtime system. It is possible for your program to throw an exception explicitly using a throw statement. The general form of throw is shown here. A throwable instance. Here, throwable instance must be an object of type throwable of a subclass of throwable. Primitive types such as integer, character, as well as non-throwable classes such as string and object cannot be used as an exception. So there are two ways you can obtain a throwable object: using a parameter in a catch clause or creating one with a new operator. So that's what here throwable demo, static void demo pro, then print try. So we are using a throw new null pointer catch, then caught inside the demo pro, then public static void main and demo. So caught inside demo proceed like null pointer exception and demo. Here new is used to construct an instance of null pointer exception. Many of Java built-in runtime exceptions have at least two constructors, one with no parameter and one that takes a string parameter. When the second form is used, the argument specifies a string that describes the exception. This string is displayed when the object is used as an argument to print or println. It can also be obtained by a call to get message, which is defined by a throwable. So throws, if a method is capable of causing an exception that it does not handle, it must specify this behavior so that caller of the method can guard themselves against that exception. You do this by including a throws clause in the method's declaration. A throws clause lists the type of exception that method might throw. This is necessary for all exception except those of type error or a runtime exception or any of their subclasses. All other exceptions that a method can throw must be declared in the throws clause. If they are not, compile time error will result. The general form of a method declaration that includes a throws clause, type method name, parameter list, throws exception list, then body of the method. Here, exception list is a comma separated list of exception that a method can throw. So the class throws demo, then static void throws one, throws illegal exception, system.out.println inside throws, throw new illegal, then public static void main string, try throws catch system.out. So output inside throw one caught java.language.illegal accept exception and demo. So then finally, when exceptions are thrown, executions in a method takes a rather abrupt nonlinear path that alters the normal flow through the method. Sometimes it is even possible for an exception to cause the method to return prematurely. This could be a problem if some methods, for example, if a method open a file upon entry and close it upon exit, then you will not want the code that closed the file to be bypassed by the exception handling mechanism. The finally keyword is designed to address such situation. So the finally clause creates a block of code that will be executed after a try catch block has completed and before the next code of try catch block. The final block will execute whether or not an exception is thrown. If an exception is thrown, the finally block will execute even if no catch statement matches the exception. Anytime a method is about to return to the caller from inside a try catch block via an uncaught exception or an explicit return statement, the finally clause is also executed just before the method returns. The finally clause is optional. However, each try statement requires at least one catch or a finally clause. So final class final demo static, you can see here we have created a procedure A, procedure B, procedure C. So in procedure 3, if something is not caught, so then finally block is used. In the same way, in procedure B, in try it is not caught, then in finally block it is caught. In the same way, even in the procedure C, um, if it is not caught, then finally it is done. So that's what here public static void main, then procedure A. So then procedure B and C is called. Java built-in exception inside the standard package java.language. Java defines several exceptional classes. The most general of these exceptions are subclasses of a standard type runtime exception. These exceptions need not be included in any methods thrown a list. Such exceptions are called as unchecked exception because the compiler does not catch uh, the to see if a method handles as thrown these exceptions. So Java language defines few checked exceptions which needs to be listed out by a method using a throws list if that method generates one of these exception and does not handle itself. Java defines several other types of exception that relates to its various class libraries. So Java unchecked exception. So arithmetic error such as divide by 0. Array index out of bound exception. Array index is out of bound. Array store exception, assignment to an array element of an incompatible type. Then class cast exception, invalid cast. So enumeration constant non-present exception, an attempt is made to use an undefined enumeration value. Illegal argument exception, illegal argument used to invoke a method. That's what here you can see illegal monitoring statement exception. These table gives us Java unchecked exceptions. So illegal monitoring state exception, illegal monitoring operations such as waiting an unlocked thread. Illegal state exception, environment or application is incorrect statement. Illegal thread state exception, request operations are not compatible with current thread state. Index out of bound exception, some type of index out of bound. Negative array size exception, array created with a negative size. Null pointer exception, invalid use of null reference. Normal number format exception, invalid conversion of a string to a numeric format. Security exception, attempt to violate security. String index out of bound, attempts to index out of the bound of a string. Type not present exception, type not found. Unsupported operational exception, an unsupported operation was encountered. In the same way, Java checked exception, class not found exception, class not found. Clone not supported exception, attempt to clone an object that does not implement the clonable interface. Illegal access exception, access to a class is defined. Instantiation exception, attempts to create an object of an abstract class or interface. Interrupted exception, one thread has been interrupted by another thread. No such field exception, a requested field does not exist. No such method exception, a requested method does not exist. Creating our own exception subclass, although Java's built-in exception handle most common errors. Sometimes we may want to create our own exception types to handle situation specific to our application. This is achieved by defining a subclass of exceptional class. Your subclasses does not need to actually implementing anything. It is their existence in their type system that allows you to use them as exception. The exception class does not define any method of its own. It inherits those methods provided by throwable. Thus, all exception, including those that you create, have the methods defined by a throwable available to them. Method throwable fill-in stack trace returns a throwable object that contains a complete stack trace. This object can be rethrown. So throwable get clause return the exception that underlines the current exception. If there is no underlying exception, null is returned. String get localized message returns a localized description of the exception. String get message returns a description of the exception. Stack trace element get a stack trace returns an array that contains the stack trace one element at a time as an array of stack trace element. The method at the top of the stack is the last method called before the exception was thrown. This method is found in the first element of the array. The stack trace element class gives your program access to information about each element in the trace, such as its method. Throwable initiate cause, throwable execution. So associates cause exception with a invoking exception as a cause of the invoking exception. Returns a reference to a exception. So void print stack trace display the stack trace. So avoid print stack trace, print stream, send that stack trace to the specified stream. Void print stack trace, print writer stream, send the stack trace to the specified stream. Void sets stack trace elements set the stack trace to the elements passed in the elements. This method is for specialized application, not normal use. A string to string returns a string object containing a description of the exception. This method is called by print line when outputting a throwable object. We may wish to overwrite one or more of these methods in exception class that we create. Two of the constructs for exceptions are exception, string message. Though specifying a description when an exception is created is often useful, sometimes it is better to overwrite toString. The version of toString defined by throwable and inherited by exceptions. First, display the name of the exception followed by a colon, which is then followed by our description. By overriding toString, you can prevent the exception name and colon from being displayed. This makes for a clear output, which is desirable in some cases. Class custom exception demo set static void test throws my exception system.out.println class test throw new exception system.out.println normal exit. So public static void main try test 45 test -2 catch and catching. So this is called test 45 and it will normally exit. So then again it will go back test -2 and there it is caught, and in that caught my exception marks cannot be negative. Then chained exception. So the concept of chained exception allows you to associate another exception within an exception. This second exception describes the cause of the first exception. For example, imagine a situation in which a method throws an arithmetic exception because of an attempt to divide by 0. However, the actual cause of problem was that an input-output error occurred, which caused the divisor to be set improperly. Although the method must certainly throw an arithmetic exception, since that is the error that occurred, you might also want to let the calling code know that the underlying cause was an input-output error. Chained exception let you handle this and any other situation in which layer of exception exists. So to allow chained exception, two constructs are two methods were added to throwable. The constructs are shown here: throwable cause exception, throwable string message, throwable cause exception. In the first form, cause exe is the exception that causes the current exception, that is cause exception is the underlying reason that the exception occurred. The second form allow you to specify a description at the same time that you specify a causing exception. These two constructs have also been added to the error exception and runtime exception class. So the chained class can be carried out to whatever depth is necessary. Thus, the cause exception can itself have a clause. Be aware that overlay long chain of exception may indicate poor design. Chained exceptions are not something that every program will need it. However, in case in which knowledge of an underlying cause is useful, they offer an elegant solution. Using exception handling provides a powerful mechanism for controlling complex programs that have many dynamic runtime characteristics. It is important to think of try, throw, and catch as clean ways to handle errors and unusual boundary conditions in our program's logic, unlike some other language in which error returns code are used to indicate failure. Java uses exceptional. Thus, when a method can fail, have it thrown an exception. This is a clear way to handle failure methods. Note that Java's exception handling statement should not be considered a general mechanism for non-local branching. If you do so, it will only confuse your code and make it hard to maintain. So that's about your third unit. Yes, any doubts? Any doubts in the third unit? Anybody? Any doubts in the third unit? Still we have a time. Anyone? Any doubt in the third part? I want to complete third unit today. By Monday, I will start with the fourth module. Yes, any doubt? Okay. So before that, let me summarize what is there in the third module. So in the third module, okay, in the third module, we have started with interfaces. So what is interface? Interface is a reference type where in the interface you can't implement anything, but you can use it as an abstract, whether it is a variable or a method. So that's what we have seen. So the interface is similar to a class in the following ways. An interface can contain any number of methods. An interface is written in a file with a Java extension with the name of the interface matching the name of the file. The bytecode of an interface appears in a class file. Interface appears in packages and their corresponding bytecode file must be in a directory structure that matches the package name. Declaring interface. The interface keyword is used to declare an interface. Here is a simple example to declare an interface. So import java.language, public interface, name of interface. So any number of final static fields, any number of abstract method declaration. So then creating an interface name, declare constant field, declare methods that abstract by default. To declare an interface, use the interface keyword. It is used to provide a total abstraction. That means all the methods in the interface are declared with empty body and are public, and all fields are public. Static and final by default. A class that implements interface must implement all the methods declared in the interface. To implement interface, use implements keyword. Why do we use interface? It is used to achieve total abstraction since Java does not support multiple inheritance in case of class, but by using interface, it can achieve multiple inheritance. It is also used to achieve loose coupling. Interface are used to implement abstraction. So the question arises, why use interface when we have an abstract class? And we have seen what is the difference between a class and interface. Class can be instantiated, but interface cannot. And class can contain a concrete methods, then access specifier used for a class and a private, protected and a public. So this cannot be done in the interface. Then implementing an interface. So how do we implement the interface? If we want to implement any interface, we have to use that in the class. So that's what here you can see: interface, my interface, class demo, implements interface. Then public void, in that we have taken method 1 and method 2, implementation of a method 1, implementation of a method 2, and creating and calling only method 1. So we can similarly we can call any number of methods. So the how do we use a using the interface reference? So here in this program, we have seen a speed is one interface where the same speed is used in a 3 different classes and different work can be done. So here just to show you how it is used, here in this case, the Audi class is doing some work and it is saying that it is 250. In a fraud class, it is doing 220, it is displaying 220. In the BMW, it is saying 300. And creating object for all the 3 classes, then displaying them. So that output of this we can see 250, 220 and 300. Then how the multiple interfaces can be done? Yes, we have just seen only one interface. But can we use 2 interface? Yes, we can use. That's what here we can see: interface 1, I1 and interface I2, where we have used 2 strings, method 1 and method 2. Then class multiple interface implements I1 and I2. Then public string method 1, then return hello from method, then public string method 2, return hello from method 2. That is multiple interface mi equals to new multiple interface, that is system mi dot method 1, mi dot method 2, hello from method 1 and method 2. So then overloaded constructor. This Java example have a class with 2 constructor, that is uh, overloaded constructor, that is dog is a class, and again in that we have 2 constructors, one is with the string and one is without string. So then dog d1 equals to new dog, dog d2 equals to new dog. Then system dot out dot println, that is d. That's what here you can see: spot no name. Then constants, can we use any constants in the interface? Yes, we can use. That's what here you can see: in the interface we have used a constant and we have told it as a 1. Same way we have used one more variable called as a constant, and here it is declared as 2, and the output of that we want to display it. So then it is displayed in the what is there in the class. So 2 will be the output of this program. So interface can be extended. Yes, it can be. So that's what you can see: the interface can be extended. Interface 1, where we have, there is one function called f1. So the interface 2 extends interface 1. So public void f2, class x implements interface 2, public void f1, f2 and f3. F1 and f2 system dot out dot println. So it is interface. So in the same way, system dot out dot println contents of method 2, f2 is in interface 2. System dot out dot println contents of method f3 of class x. So class extending interface, public static void main, interface v2, reference variable of interface 2, v2 equals to new x, v2 equals to f1, v2 equals to f1, f2, then x, x1 equals to new x, x1 dot f3. So contents of method f1 in interface 1, content of method f2 in interface 2, then contents of method f3 of class x. So nested interface, we can declare interface as methods as member of a class or another interface. Such an interface is called as member interface or nested interface. Then import java.utility. So here you can see test and testing. So implements test.s. So in that case, we have, there is a method called as a show and again show. Then class A, public static a public static void main, test dot y, then object. So then testing, t equals to new testing, object equals to t, then show. So then packages and member access, importing package. A Java package is a group of similar types of class, interface and subpackage. Package in Java can be categorized in 2 forms: built-in package and user-defined package. There are many built-in packages such as Java language, AWT, JavaX, Swing, Net, IO, Utility, SQL, and etc. Package fundamentals. A package is a collection of related classes. It helps organize your classes into a folder structure and make it easy to locate and use them. More importantly, it helps improve reusability. Each package in class has its unique name and organizes its class and interface into a separate namespace or a name group. Package, we have seen the package is similar like folder. Within that package you may have any number of class. That's out here. Package, we have a shape, and in that we have a circle is one class, square is another class, and triangle is another class. And we are trying to calculate, pass the values and calculate the area for triangle, circle, and a square, and pass value for areas 3 and 5, for triangle as 3 and 5, circle as 5, and square as 10. Then along with that we have a built-in package. So there are so many built-in package where we are using, which is already developed by someone, and we are using them. That's what here. These packages consist of large number of classes which are part of Java API. Some of the commonly used built-in packages are java.language, java.io, java.utility, then java.applet, java.awt, java.net. User defined package. There are the package that are defined by the user. First we create a directory. My package name should be same as the name of the package. Then create the my package, my class inside the directory, with the first statement being the package name. Static import, Java static import. The static import features of Java 5 facilitate the Java programmer to access any static members of class directly. There is no need to qualify it by a class name. The advantages of static import: less coding is required if one has access any static member of a class oftenly. Disadvantage of static import: if you overuse the static important features, it makes the program unreadable and unmaintainable. Import static java.language.system class static import example. So public static void main, then out.println hello. Now no need of out.println, that is Java. Exception handling. An exception is an abnormal condition that arises in a code sequence at runtime. In other words, an exception is a runtime error in computer language that do not support exception handling. Error must be checked and handled manually, typically through the use of error codes. This approach is as cumbersome as it is troublesome. Java's exception handling avoids these problems and in the process brings runtime error management into the object-oriented world. Exception handling fundamentals. A Java exception is an object that describes an exception, that is error condition, that has occurred in a piece of code. When an exceptional condition arises, an object representing that exception is created and thrown in the method that caused the error. That method may choose to handle the exception itself or pass it on. Either way, at some point, the exception is caught and processed. And we have seen what is Java exception handling. We are using 5 keywords, that is try, catch, throw, throws, and final. So that's what we have seen. And an exception type. So we have a built-in class called as a throwable. Again, in that throwable, it is divided into exception and error. And again, exception is divided into runtime exception and customized exception and error. So then this is what the one program where it shows without not able to catch, not using a try and catch block here. So then in this class, we are showing how the main subroutines can be used and how whether it is caught or not caught. So then here you can see try and catch is used and trying to catch divide by 0. Then here import java.utility random. So then class handle error, public static void main, int a equals to 0. So we have seen here try catch block. So BCA. So here R is dot next integer, R dot next integer 1, 2, 3, 4, 5 divided by B slash C catch arithmetic exception, then system dot out dot println division by 0. So then here displaying a description of an exception, we can display this description in a print line statement by simply passing the exception as an argument. This is possible because throwable overrides the toString method, so that it returns a string containing a description of the exception. Multiple catch clause. If some cases more than one exception could be raised by a single piece of code, to handle this type of situation, you can specify 2 or more catch clause. Each clause, so that's what here you can see, we can use a multiple catch. In this program, 2 catches are used. In the same way here, the same thing, but showing how the multiple catch, one for generic exception class and another for a arithmetic exception. Can we use a nested exceptions? Yes, we can use a nested exceptions. So nested means what? One within one more. So here in this program, you can see try within one more try. So and we can use a catch. Same way here in this also try and catch block where try within one more try. Either it can be within a class or within a main class. Then we have one more thing called as a throw. So what this throw is doing, again in a throwable object, where the parameters we used as a catch and a new operator. So here you can see the catch is used and a new operator. And the same way, null point exception, no parameters and a string parameters can be used. So then throws, so it is a clause, a type of exception where the method might throw. So and in this it is necessary for error or a runtime exception. So then finally block, where in case if try and catch is not caught, then finally can be used. So then we have a built-in exceptions. So these are the list where unchecked exceptions are done. So in the same way, checked exception, these are the checked exceptions. And creating our own exception subclasses, not only built-in, but we can also create our own subclasses. So that's what here we can use so many user-defined, or how we can use our own exceptions. So then this is a program where it shows how the try and catch, where it is moving from a function to one more function. So then chained exception, one within one more, how we can use. So then using the exceptions. So that's about the thing. So we'll stop here. We'll continue in the next class with the next unit, that is 4th unit. Okay. So answer your attendance. Answer your attendance. 1.
Yes, ma'am.
2. USN 2. 3. Answer your attendance, please. So everyone is, how many are the 54? 2, 3, 3, 4.
Yes, ma'am.
6.
Yes, ma'am.
7.
Present, ma'am.
8.
Yes, ma'am.
9.
Present, ma'am.
10.
Yes, ma'am.
11.
Yes, ma'am.
12.
Present, ma'am.
13.
Present, ma'am.
14.
Present, ma'am.
15. 15. 16.
Yes, ma'am. Present, ma'am.
17.
Yes, ma'am.
18.
Present, ma'am.
19.
Present, ma'am.
20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24, 25,
Yes, ma'am.
26,
Present, ma'am.
Present, ma'am.
27,
She is also present, ma'am. Her mic issues.
28, 29,
Present, ma'am.
Yes, ma'am.
30, 31,
Yes, ma'am.
32,
Present, ma'am.
32,
Present,
33,
ma'am.
34, 35,
ma'am.
36,
Present, ma'am.
37,
Yes, ma'am.
38,
38 is present, ma'am.
39,
Present, ma'am.
40,
Yes, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43,
Present, ma'am.
44,
Present, ma'am.
45,
Present, ma'am.
46,
Present, ma'am.
47,
Present, ma'am.
48,
Present, ma'am.
49, 50,
Present, ma'am.
51,
Present, ma'am.
52,
Present, ma'am.
53,
Present, ma'am.
54,
She has put in chat box, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58,
Present, ma'am.
59, 59.
She is present. She is present, ma'am. Network issue.
Okay. Okay. Any problem? Anything? Any doubts?
Ma'am,
Yes.
49 present,
Yes.
ma'am. 49 present, ma'am.
Okay.